This is the chuck I picked up from Mike O'Connor. I just finished disassemble, fully clean, and reassembled. It's working great. It's a buck adjustable chuck. Just got to make the back plate for it now. 6 jaw, solid jaws, but it's brand new. It's older chuck, but it's never been used, so it's beautiful. There wasn't a chip in it. All the old grease had dried out. That's what's on. That's what's for today. We'll get some measurements here on the chuck so we can get this designed up to fit. First, what I did is I measured the ID here. Got that. That was about 370 inside here. Then I figured out what the depth of these adjusting pins. How far in can they go? Well, the full depth of screwing one in is only about 75 thousandths. And one of these pins here only comes into this area 75 thousandths. So I backed them off and I set them each at around 30 thousandths and measured. So in between them, I came up with 6,310 on the measurement, and that gives me about 30 thousandths clearance all the way around, and enough room to adjust it actually all the way to one side. Bolt circle, put a couple of gauge pins in that fit, and just measured across, and then subtract the diameter of one of the pins, and that'll give you the bolt circle. And it's evenly spaced, six holes. So what they are is there's enough clearance. This is a 7/16 14 socket head cap screw, and there's enough clearance in there so you can move that about 20 thousandths each side. I think it was. Yeah, 4,375 and 472, so about 40 thousandths total. So it's about 20 thousandths of play in there, which is plenty to be able to shift this around. The depth, I used my depth mic on there, boom, and I went around and got an average. It's 0.8 basically all the way around. So we'll this is 1 inch thick, and I'm going to take off a little more than that, 0.8. I'm going to take off 820 in depth, and we have a little 150, 160, 70 thousandths, something like that out here, and that's going to come up over this ledge, and it won't touch here, but what it will do is give me a little bit of a gland so that dirt and chips can't get in here. And so I'm going to cut that outside to the outside diameter here, a little bit shy of that. It's just so I have an overlap and keep dirt and crap from getting in there. And here's our plan. So what I'm going to do is I'm going to machine this down for this portion here to go inside this recess. I'm going to leave a flange on it, the little bit that's left. I'm going to leave as a flange that will come out over this part here to act like a little bit of a dust cover so chips can't get down and in there. I'm going to leave a little bit of room when you bolt this up with your 6 bolts that you got sticking out there, right? So that will be up on there, and the recess will be going inside, so it will bolt up tight, and there'll be about 20 thousandths is what I'm going to shoot for clearance on this portion here. So that flange doesn't touch the chuck. It's just act as a labyrinth so chips can't get down and inside. And we have a 6-bolt hole pattern to do, and really that's about it. Turn the diameter, turn this outside to a diameter also, and put in the bolt holes. So we'll do that, the bolt holes on the mill, and we'll do the turning first, of course, on the lathe. Now we're going to mount that right on the spindle to turn it. We're not going to put it in a chuck. So we'll go to the lathe, we'll pull off the other chuck, mount this on. But I'm just going to buff this out a little bit with Scotch-Brite, make sure it's nice and clean, and make sure it makes good contact on the spindle. This chuck weighs about 70 pounds. It's pretty heavy. Make sure you use a support for especially big chucks, or if you got one of those little cranes or something. I haven't built a crane or anything yet, so I use a nice little support I made, and it slips under there. I got it back here, but I don't put this on super tight, so it doesn't take much. You don't need to. If everything's clean when you put it together, you don't need a lot of force to cinch them up. I take a stick, just kind of cinch it up on there. Gives me two handles. Pick it up off there. Let's make sure it's nice and clean before we test fit this plate on. I like putting the key on top myself so I can see where it's at. Now I very lightly put some blue on the inside after I cleaned it up with some Scotch-Brite. I just put it back here so I can snug it up. That's it. You know, just put it on and take it off. Yeah, that's contact here on that inside, all the way around in here and on the inside. So not too bad, pretty good. Now it's not something you could spin because of that key. Now I could take the key off, I guess, and try it out, but that fits pretty good. First I'm going to do is I'm just going to face this off, and I'm using the facing tool I made for those inserts. It's got a nice big radius on it. First, gotta get everything set, huh? That might be a little slow. Getting a little smoke. Thing has been packed in oily paper. Might get it in just one pass here. It should come out pretty good, looks like. Oh, nah. Super nice finish. Only one little, let's see, right, I don't know if you can see it right there, hardly just a tiny little dot of an inclusion. I'll be okay. But that's all cleaned up, one pass, that's good. Alright, we're set up here to turn the OD down to 7 inches, 430. And what I have in here is I have a 5/8 boring bar upside down. This is a nice one I picked up on eBay. It's a solid carbide. I'm doing this upside down. I'll be turning the lathe in reverse, and that helps a little bit with chip control. The chips will go down instead of up or all over the place. But also I need it for the for clearance. I couldn't quite get that clearance the other way, so this is going to be really nice. And we're just going to turn that whole OD down, and then we'll start turning down the other OD to fit in the chuck. I'm going to use my new big calipers, which are pretty nice. So we're about 8, 1, 15. So we have 7, 430. It's about 7.5. So we have a good ½ inch, a little more. So we have about 0.6 inches to take off. Very nice finish. Very, very nice, and a little small inclusion, but that's what's going to come out. So hopefully we don't have too many inclusions or anything. That was just a little bit of a cleanup. Dialed in at 30 thousandths. We'll see how that goes on this. Go 50 thousandths here now. Let's see how that goes. That went really well, that 30. We're turning 350 RPM. So that worked out really well. We'll just keep up the 50. I think that's pretty good. Last cut, hopefully. Oh, we're at 7,433. So I'm just going to call it good. This is not a critical dimension at all. Plus or minus 5 is just fine. So we're going to call it 7,432. Close enough. It's a non-critical dimension. Now the next dimension will hold a little better tolerance. The next diameter is going to be 6 inches, 315 thousandths, and it's going to come in 820 thousandths. So we want 820 in, and it's going to come down to, we're going to take about a little more than ½ an inch out on the diameter, and over an inch out on the total diameter, I should say. I have a dial indicator on the ways for my measurement in. I just butted this up against the face. And we'll just continue to take our 50 thousandths cuts. That was working really well. That's 780 thousandths roughly in. Might leave me a little room for cleanup. Final here, so we're bringing the big boy out, Even though I'm comparing the two with the caliper, and I'm usually within 1,000th of each measurement, so that's pretty nice to know. So I'm 6 inches 356. I'm just going to double check that. 355. .355, even on the caliper here. So we're at 6.355. We go down 6.315. We have 20 thousandths to go. We'll do it in one cut, and then we'll be adjusting our depth and cleaning that face. Yeah, I'm measuring 316, so that's just fine. We're shooting for 315, and it's pretty warm. This is pretty warm, so thousandths over, it'll probably shrink down a little bit. Now we're going to fix our depth and face that. All right there, I'm about 10 shy. We're just going to go in and take a cut, and then we'll clean up the last 10. I'm right at 800, but I wanted 820, so I'm going to get the depth mic and measure that. There's a little burr on the edge, and I'm going to chamfer that all when I'm done, so we'll just kind of clean a little spot. That's pretty good. Actually less than 1,000 shy of 800. About half a thousandth maybe. Not very much. We'll make 2 more 10,000ths cuts and call her good. Another check. $19. Call it good. Not a super critical dimension. I just want a little tiny bit of clearance from the chuck so it bolts up tight. So here's the boring bar. That's a... Oh, there we go. That's the insert. That's a pretty small insert. That's like a 21.15 type insert. No chip break or anything on it, just flat. Worked great on these things. Here's the other boring bar here. I'm going to reach around and use this back edge to chamfer that back edge. I don't have a tool that nothing comes far enough and a tool enough to reach around this back side. I wouldn't mind truing that up, but until I figure something out, that's going to have to be just fine. I think we're pretty much done with this. Pretty warm still. I'll let it cool off, take some more measurements before I remove it. And I think it's good to go for the drilling.